You don't have to do the mesh the same way I do it, but I find it good and useful to be consistent, and have all of your circuits going the same direction in the same problem. Doesn't matter if you go clockwise or counterclockwise, and you don't have to have them all go the same direction, but it makes your life a whole lot easier if you do, so you don't have to worry about the signs. They'll all have the same signs. So I am going to draw my mesh like this. So I'll have these three loops, and I'll call this one I1, and this one I2, and this one I3. Except you can't really see the red. Okay. And then we're going to write our mesh equations. So for mesh 1, as you go into the negative sign of a voltage source, that's negative. So if we're going around our loop this way, we're going into the negative terminal, so that will be negative. So it's -6. And then across every resistor, we need to get a voltage, and a voltage is a current times a resistance. And in that 4 ohm resistor, the only current going through it is I1. So this will be plus I1 times 4. And then as we continue going around, we come to the 30 ohm resistor. So it'll be 30, but this time there are two currents going through it, I1 and I2. And it's always going to be when the resistor is being shared between the two meshes. If you did like I said and you made them all the same direction, it'll be positive for the current in the mesh that you're on and negative for the shared current. So this will be plus 30 I1 minus I2, and then I'm done with that mesh, equals 0. And now I'll do mesh 2. And I'll start up at the top at the 6 ohm resistor, and the only current going through that one is I2, so that's 6 I2 plus, and then when I come to the 20 ohm resistor, I've got I2 and I3, so that'll be 20 times I2 minus I3, plus at the bottom I have the 10 ohm resistor, and then in that one it's only I2, so 10 I2. And then I come to the 30 ohm resistor, and that'll be I2 minus I1 equals 0. And anytime you have a shared resistor, you should have in two different equations the opposite expression. So like for I1, I have 30 I1 minus I2, and in I2 I have 30 I2 minus I1, which tells me in my third mesh I should end up with a 20 I3 minus I2. So when I go to my third mesh here, and I'll actually start with that 20 ohm, and so when I come to the 20 ohm, it's 20, and it's I3 minus I2, and then plus 5 I3, and then I'm going into the positive terminal of that voltage source, and that was 40 volts, so that's plus 40 equals 0. Any questions? Okay, so now I will just simplify these equations, and so the top one, 4I1 plus 30I1 minus 30I2 equals 6. And then the second one, I have 6I2 plus 20I2 minus 20I3 plus 10I2 plus 30I2 minus 30I1 equals 0. And then the bottom one, I have 20I3 minus 20I2 plus 5I3. I'll go ahead and take the 40 to the other side, equals negative 40. And then I have 34I1 minus 30I2 plus 0I3. I'm just putting that in to help me solve. And then the next one should be minus 30I1 and then 20 plus 10 is 30 plus 30 is 60 plus 6 plus 66I2 and minus 20I3 equals 0. And then the last one is 0I1 minus 20I2 plus 25I3 equals negative 40. Now, on a test, I doubt that you would have to do 3 equations, but we'll go ahead and do it now. Let's see. So it was 34. This is the TI-36 that I told y'all you should get. Minus 30, 0, 6, negative 30, 66, negative 20, 0, 0, negative 20, 25, negative 40, and I get I1 is negative 0.825, and I2 is negative 1.135, and I3 is negative 2.508, and I'll write those down. So. I1 is negative 0.825 amps. I2 is negative 1.135 amps, and I3 is negative 2.508 amps.
So you just set up one big system of equations to get the 3 of those values?
Mm-hmm. And that's how I always do it. And if you have, I didn't bring it with me this time, but it's just the little handheld TI-36 that I was using, the computer version of that. That'll do that. You can also solve the systems if you have a TI-84 or something like that. But I strongly recommend that you get the calculator, the TI-36. I think that's like $20. So, yeah, and you set it up, and then you just plug those numbers in, and you get it. Okay, so but the question asks for the power supplied or absorbed by the 6-volt voltage source. Now, notice the way we drew I1. I1, the way we drew it, is going into the negative terminal of the voltage source. So when I do power, P equals IV, I, as drawn, was negative, and it was negative 0.825. And then I look at the fact that it's going into the negative terminal of the voltage source, so that is also negative. So times negative 6, and that gets me 4.95 watts. And since that's positive, it's absorbing.
was your F for I1, L2?
I'm so, oh yeah, is that what you were asking? Yeah.
So what does supplying and absorbing power mean in terms of like the circuit? Like what is it doing when it's absorbing power?
So it means it's charging.
It's charging back up.
Yeah, if we're talking about a voltage source, a resistor is always going to be absorbing because it's always taking in energy. It's always heating up. But for a voltage source, if it's supplying, that means it's providing the voltage. If it's absorbing, it's charging.
Okay.
I got it.
Okay? All right, so now,
These are the variables in just to make sure I got it. Okay, I see.
okay, so now the next part was something that I wanted to make sure that we took a look at because it's really easy to make a mistake. So I want to make sure you don't make this mistake in any kind of problem. So I just thought I would use this as an example. So it says if the node below the 6-volt voltage source is marked as ground. So I'm going to make that ground right there. What is the voltage relative to ground between the 40-volt voltage source and the 5-ohm resistor? So the question is, what is the voltage right there? That's the question. And it's real tempting to say the voltage right there is 40, but it's not. And the reason it's not is because we put ground over here. And there's a resistor in between ground and this voltage source. If I had put ground beneath the 40-volt voltage source, then I could say, yeah, the voltage up there is 40. But it's not, because I have the ground is over here. So to figure out what the voltage is, I need to figure out what the voltage drop is across that 10-ohm resistor. All right, so we know that I2 was negative 1.135. And we drew it to where it was going to the left. So for this part of the problem, I'm going to say, I wonder what color might show up. Let's see if this shows up. So for this part of the problem, I'm just going to say that this current, and I'll just call it I, that I is 1.135 because it's going in the opposite direction that I2 was. So I2 was going to the left and it was negative, so if I draw it going to the right, it'll be positive. So the voltage drop across the 10-ohm resistor, so this is just the drop across the resistor, is IR. So V equals IR, and when we say V equals IR, we mean we're talking about the voltage change across something. We're not talking about absolute voltage, but the voltage change. So it's 1.135 times 10, which is 11.35. So that's the voltage change. So is the voltage higher on the left or on the right? I know that there's a difference of 11.35, but is it, and I know that this side is 0 because it's connected to ground. That side is 0. So is this side 11.35 higher than 0 or 11.35 lower than 0?
Higher. Wait, which side? Which side?
The right side.
It would be higher, wouldn't it?
It's lower.
It's lower?
It's lower. Current flows from higher voltage to lower voltage, except for inside a voltage source. The whole point of a voltage source is to increase the voltage. Otherwise, current is always going to go from high voltage to low voltage. And so on this side, we had 0. So on this side, we have negative 11.35 volts relative to ground, because it's always relative to something. And that also makes sense because if we're saying the current is going in that direction, then it has to be losing voltage. There's a voltage drop. And that's why I changed it back to a positive current, because it's easier for me to think in terms of a positive current. So a positive current going through a resistor, you're going to have a lower voltage after you've gone through the resistor, because you've lost energy. So this is 11.35. Now we look at our voltage source. Our voltage source, it's got negative at the bottom and positive at the top. That means the top is 40 more than the bottom. So the voltage at the top of the voltage source is 40 more than the bottom. The bottom was negative 11.35, so that makes the top 28.65. Relative to ground, where we drew ground. So that was kind of like a conceptual thing to hopefully explain some stuff. Are there questions on that?
You could have also put I2 in the same direction, right?
Absolutely.